Oh, hi, Mr. Lee here. All right, this practice is going to be on solving exponential equations using exponent properties. So the main strategy we're going to be using is, given that this is an exponential equation, you're going to have exponential terms on both sides. What we're going to attempt to do is set the bases equal to each other, okay? And then if we can successfully do that, that should allow us to then set the exponents equal to each other, okay? So if the bases are the same, by logic, the exponents will be the same. Okay, so we'll see plenty of examples. You'll see what I mean. Let me copy this equation over. Okay, so it's 2 to the power of 4 minus 3x equals 16 to the power of 2/5. Some nasty numbers, got some fractions here, but this 16, if you'll notice, is a nice power of 2, right? It's going to be the same as 2 to the power of 4. Okay, so all I'm going to do in this next step, everything's going to stay the same. All I'm going to do is change this 16 into what I know it's equal to. I'm replacing the 16 with 2 to the power 4. It's because 2 to the power 4 is the same thing as 16, so I'm allowed to do that. Okay? So once I do that, check it out. Now you have the same bases. 2 here, 2 here. Let's apply some more exponent properties, and then you'll see how the exponents will actually be equal to each other. Okay? So I'm going to apply my power to a power, right? If you have a power to a power, you have 2 to the power 4 to the power of 2/5. That exponent property means you multiply your 4 and 2/5. Okay? So let's see what 4 times 2/5 is. It's going to be the same as 1.6. Okay? I think we'll just use decimals for now. Okay? If you want to, you can, keep it in its fraction form. I'll just use the decimal just because I have this calculator open. Okay? So this is no longer going to be 2 to the power 4 to the power of 2/5. It's going to be 2 to the power of 1.6. Right? That's just simplifying 4 times 2/5. Okay? So now, check this out. This is where the next application comes. If you are successfully able to set these bases equal, right, then that means, by logic, the exponents have to be equal. So I'm going to forget about the bases now. I don't care about the 2's anymore, right? Because my x term that I'm trying to solve for is in the exponent on the left side. And then the right side's exponent should be equal to the left side's exponent. Okay? So notice what I did here. Okay? All I did was form a logical argument that if I have the same bases, then the exponents have to be equal to each other. So I'm just able to set those two together, get a simpler equation, and I'm still solving for x. Okay? So from here, pretty straightforward. You guys have seen equations like this before. I can subtract 4 on both sides, divide by -3, right? I'll let the calculator do the work for me. So subtract 4 on both sides. That's going to be 1.6 minus 4. And then I can divide everything by -3. So this whole thing should be, oh, I don't want that. Divide by -3. There we go. Okay, so that's where we get the 0.8. Right? You can simplify, some of these numbers beforehand if you want to. Like what? 1.6 minus 4 is going to be what? A negative 2.4, right? And then -2.4 divided by -3 will give you the same 0.8. Okay, but I just let the calculator do the work for me. And we got our x value by itself. Okay, so I'll show several examples. Use what you need, but I'm pretty sure it's going to be this same process, right? Find a base that's equivalent on both sides, and then once you set those bases equal, you can then set the exponents equal. Okay, so here's another example of that. This is 5 to the power of 7x plus 5 equals 125 to the power of 2x minus 7. Okay? So I have a base of 5 here, base of 125. Hopefully you guys know that your 125 can be rewritten as 5 to the power of 3. Right? 5 squared is 25. 5 to the power of 3 is 125. Okay? If you need to check, just check. Just start guessing. Use a calculator. Right? That's obviously too big. Too big. 5 to the power of 3 is the same as 125. So all I did, right, this is mathematically sound. You're allowed to, at any point in a step, change the way a number looks to something that's equivalent to it. Okay? So now we're going to apply our distributive property. All right, we have a 3 times a 2x minus 7, along with your exponent properties, right? So let's see. Let me copy this all over again. This will now be in the exponent times a 2x minus 7. I'll clean this up, don't worry. Okay, so it's going to look like this. This is the same thing. Okay? So power to a power, you're multiplying the 3 along with the 2x minus 7. Don't forget the parentheses. And then this is what I was saying, right? We can distribute this in the next steps to continue our solving, right? But we got the bases equal, 5, 5. So that means, by logic, the exponents are equal. So I don't care about the 5 anymore, right? My x terms are only in these exponents, so I'm going to basically take them out a bit. But really, I'm just creating another equation that communicates the same logic. Okay, so 7x plus 5 must be equal to 3 times 2x minus 7. And then we just have a linear equation to solve. Okay, so I'll do this quickly, but you can always pause and rewind if you need to. So 7x plus 5 is equal to a 6x minus 21. Just applied my distributive property. I'm going to subtract x on both sides. We get that. And then I'm going to subtract 5 on both sides. We get a negative 26. Okay, so x equals negative 26. Let's see if we're correct. That's good. Okay, so I'll finish up the exercises, but like I've been saying, use what you need. So in case you need to see more, let's keep going here. 9 to the power of 3x minus 10 equals 1 over 81 to the power of 1/6. Okay, so this one is a little bit tougher because we have this fraction. Okay, so it's the good thing is it's still an application of your exponent properties. Okay, so you have to know your exponent properties. This 81 is nice because this is going to be the same thing as 9 squared. Okay, so 1 over 81 is the same thing as 1 over 9 squared, which then I can change into 9 to the power of negative 2, right? So remember, we can always flip between numerator and denominator as long as we keep the same base and change the sign of the exponent. Okay, so just to be really thorough, I'm going to keep going here. These are all equivalent forms. 1 over 81 is the same thing as 1 over 9 squared. And then 1 over 9 squared is the same thing as 9 to the negative 2. Like that. Nope. Like this. There we go. Right? 1 over 9 squared, same thing as 9 to the negative 2. So now we have this same base. 9, 9 here, 9 here. That's what we wanted. Okay? So let's apply more exponent properties. I have another power to a power, a negative 2 to the power of 1/6, or it's a negative 2 times a 1/6, right? Power to a power. So we can change this to negative 2/6. Okay, I'm going to leave it unsimplified for now, but negative 2 times, let's see, I got to get in the exponent, or in the parentheses, negative 2 times 1/6, we'll do it like that. Okay? So, same thing, right? I finally successfully got the bases the same. So by logic, I can set the exponents equal. Just like that. All right, I'm going to leave everything in this form, but if you want to, right, just change this to what, a negative 1/3. Right, negative 2/6, the same thing as negative 1/3. Okay, but it's just, this is your algebra. I'm going to add 10 to both sides. 3x is equal to a negative 2 times 1/6 plus the 10. And then we're going to divide everything by 3. there's our answer, 3.2 repeating. So I think we do want the fraction version for this one because I'm not sure Khan Academy will accept the repeated decimals. They might, but I don't want to risk it. So let's just convert this to a fraction. Should be 29 ninths. Okay, so 29 over 9. There we go. Uno más. Okay, so another example of having a fraction. This is a 1/8, so we're probably going to have to use a negative exponent with your 2. Okay, hopefully you realize that 8 is the same thing as 2 to the power of 3, so there should be a connection there. Okay, so we got what? 6x plus 7 in the exponent here equal to a 1/8 to the power of a 1 minus 5x. Okay. So, 1/8 is the same thing as 1 over 2 to the power of 3, which is the same thing as saying 2 to the power of negative 3, like that, right? All exponent properties. 1 over 2 to the power of 3, same thing as 2 to the negative 3. Okay, so now bases are matching. Let me apply some extra exponent properties before we get rid of the base altogether. I can do a power to a power here, right? So again, you're multiplying. So this is going to be what? Negative 3 times 1 minus 5x. Negative 3 times 1 minus 5x, like that. Get rid of that parentheses. Okay, power to a power. Multiply the exponents. Now we set the exponents equal by logic. 6x plus 7 equals a negative 3 times 1 minus 5x. Okay, so same steps as all the other equations. I'm going to go through this a little bit quicker, but again, pause and rewind as you need to. All right, let me distribute. It's negative 3 plus a 15x, negative and negative. Don't mix up the sign there. And then I'm going to choose to subtract 6x on both sides. I just want to keep this a positive number. Why not? Okay, so I'm going to subtract 6x on both sides, which gives me a plus 9x. Right, 15x minus 6x is 9x. And then I'll add 3 to both sides. That gives me a 10 equals 9x. And then divide 9 on both sides. We get a final answer of 10 ninths. Okay, 10 ninths. We'll keep it at that fraction. I don't want to deal with a ninth as a decimal. There you go.